Hello, this is the first video of a second vector series for OCR AS Core Pure Further Mathematics. It covers the vector equation of a line in 2D. The general form of a vector equation of a straight line is that r equals a, which is the position vector of a point on the line, plus lambda, a scalar multiple or parameter, d, where d is the direction vector. If we do a sketch, what we're thinking about is that from the origin, we jump onto the line using vector A, and then we go in either direction along the line, given by lambda, where the direction of a line is given by d. Now, lambda can be positive, negative, or 0. It can be an integer or a fraction. So you might like to think that if d is in the direction shown, that lambda being 1 or more will take us along the line from A to points along the line in that direction. If lambda is negative, the points will be in the other direction, and if they're fractional, they will obviously only be smaller movements along the line. In this example, we are asked to find a vector equation of a line that passes through the point minus 3, 2 in the direction 2i plus j. You'll remember from the previous video series that I and j are unit vectors in the x and y directions. Let's take minus 3, 2 as our a vector. For r equals a plus lambda d. A being minus 3, 2, and then we just need lambda, which is our variable parameter, and the direction we know is 2, 1. This therefore then is the vector equation of that line. If we're asked to find a vector equation of a line that passes through the point, we're looking for r equals a plus lambda d. So let's use 3, 2 as a, and then we're just looking for direction vector. Now if we think of d as being the direction vector AB, between those points A and B, we can see that that direction vector will be 2, minus 1, minus 3, 2. In other words, minus 1, minus 3. This gives us a vector equation. You'll note that it says a vector equation. We could, of course, equally well have used the 2 minus 1 as our getting onto the line point, and then I'll use a different parameter just to not cause confusion. We could then have used the direction BA instead as our direction vector, which would have been 1, 3. So it doesn't matter which of these vector equations we use. Vector equation of a line is not unique. The two lines are parallel if the direction vectors are the same or one is a multiple of the other, and we saw this in the previous series. D, which we found as either AB or BA in the last slide, could easily have been a multiple of minus 1, minus 3, or 1, 3. So we could have used, for example, 2, 6. Two vector equations represent the same line, or are collinear, if they are both parallel and share a common point. You'll notice that the gradient of a line is given by d2, d1, where we can write that the direction vector d are the elements d1, d2. In the next session, we will consider the vector equation of a line in 3 dimensions.